Hi there. In this video, we'll look at how to draw a Lorenz curve from a given income distribution. Now, normally we would get income distribution data from government reports, but for our exercise, we'll create our own example. And for the best learning experience, I find it useful to create a spontaneous example, given that doing this video, and for the purpose of the video, I'll create a spontaneous example by drawing a set of random numbers. And the numbers will represent income shares for the different income groups. And since we are working with quintiles, that's 20% grouping, that would mean that we would have 5 groups altogether. As soon as we draw 4 numbers for 4 income groups, the 5th one would be automatically implied, since the 5 income groups' incomes must add up to 100%. So we only need 4 numbers, and the 5th one would be automatically implied. So what I've done is I've put together a bunch of numbers in a box and to draw randomly from, and so I'll go ahead and draw them. Then once we have the 4 numbers, then we can find out what the 5th number would be, and we can also then fill in the table with the income information. So drawing the numbers here. 1, 2, 3, 4. Okay. Let's see what we have. We have, all right, 48%. That's pretty large. And then we have 4%. That's pretty small. Then we have 10%. And we have 14%. So let me write these down. We had, let's see, these are the income shares that we had. We had 48%, we had 4%, we had, I think 14%, and we had 10%. Okay. These, for the 4 groups, would add up to, you can calculate the summation, there would be 76%. And so that would tell us that for the remaining group, the income share is whatever would help us to get the 100%. So it would mean 24% for the remaining group. So we have 5 different groups' income shares. 4 of them we randomly drew, and the 5th one was automatically implied, and so then we are ready to put these into the table. Now remember that in the table we are rank ordering the different groups, going from the poorest quintile to the richest quintile. So the poorest quintile must have the lowest of the income shares by construction. The second poorest quintile could not have less income share than the poorest quintile, because then we would have reversed the grouping. So looking at these 5 numbers, the lowest one that we have is 4%, so that is the income share for the poorest quintile. The next lowest one is 10%, so that must be the second poorest quintile, and then 14%, then 24%, and then 48%. That's the richest group. These are income shares of each of the 5 groups. They add up to 100. What we need to do for constructing the Lorenz curve, where we measure cumulative population share or percentage, and on the vertical axis we measure the cumulative income share. So it's measuring cumulative income share against cumulative population share. And so with this information that we have for our example, we can then calculate the cumulative shares down the table. So when we have looked at only the first group, we will have seen only 20% of the population. When we will have seen the second group as well, we will have cumulatively seen 40% of the population, and then so on and so forth, 60, 80, and then when we have the fifth group included, we will have seen all of the population, 100%. Income-wise, when we have seen only the first group, cumulatively we will have seen only 4% of the income, comes from there. When we have added to that the second group, then cumulatively we will have seen 4 plus 10, 14% of the nation's income. When we add the middle 20%, then we add the 14% cumulative from before, plus the 14% accruing to the middle group, so that gives us 28%. Cumulatively, when we add the next group, we get 52%. And then this makes sense. 52% of the national income accounted for by the bottom 80%. Add to that 48% of the income, and we will have seen 100% of the income. So these two columns are what we need for constructing the Lorenz curve, since Lorenz curve is looking at cumulative income share vis-a-vis cumulative population share. So let's plot the graph. But in the process, a couple of pointers to mark. First is that this point, the origin, is clearly part of the income distribution for any given situation. It's basically saying when we have not counted any person yet, we will not have seen any income yet. So 0 goes with 0. This is the other trivial point that's part of all income distributions and all Lorenz curves. And because that's saying that when we have seen all of the population, 100% of the population, we must have then seen 100% of the income. So these 2 points are clearly part of the Lorenz curve. What's the task after that is to fill in the middle, basically wondering where are the points in between. So what I've done is I've gone ahead and drawn one extreme example, extreme in the sense that if everyone in the country had the exact same income, then what would it look like? It would basically give us 20% of the population having 20% of the nation's income, another 20% of the population having another 20% of the nation's income, so cumulatively 40% of the population having 40% of the income, 60% of the population having 60% of the income, so on and so forth. It's proportional because as we keep adding more people, we keep adding more income. As long as they have the same income, it just keeps going up proportionally. And it gives us this straight line going from 0 to 100, the 0, 0 to the 100, 100. And the straight line, this diagonal, is the Lorenz curve for a situation of perfect equality. And so we can go ahead and label that this diagonal line is the Lorenz curve, or the line of perfect equality. And it's useful to keep that in mind because it sort of serves as a benchmark. The other note to make is that we could envision the other extreme, whereby no one, or almost no one in the country has any income except one person or one family, and that person or family has all of the income. In that situation, we would see this sort of scenario where when you've seen the bottom 20% of the population, the income that they have cumulatively is 0 because they have no income. You add 20% more, 20% more, 20% more, and more. No one has any income, so cumulatively we are seeing 0 income even though we are counting increasing portions of the population. Up to 99% or 99.9%, 0 cumulative income. And then when we capture the last person or the last family, that's when we see all of the income all at once. So this extreme scenario where the Lorenz curve moves along the horizontal axis until the last point, and then goes all the way up vertically to the 100 point, that would be the extreme case of perfect inequality. Inequality could not be any more accentuated. So we could label this as the line of perfect inequality. Okay. Now, in reality, in practice, there's not a single country where the Lorenz curve is like that, because there's not a single country where income is shared exactly equally among all people. There's also, in practice, no country or community where it looks like this, the extreme case, the line of perfect inequality, because we have no situation where all of the income goes to just one person and no one else has any income. So these are meant to be benchmark visualizations of what perfect equality situation would look like on a graph like this, and how perfect inequality would look like. In practice, we will have something in between, and the question is, where in between? And that's what we are trying to draw. The Lorenz curve for this example would be based on these cumulative shares of population and of income. So if we take the very first combination, for the first quintile, we will have seen 20% of the population, but income-wise we will have seen only 4% of the income. So 20% goes with 4. So it's, and this is sort of a freehand sketch. It's roughly about there. Then when we have cumulatively seen 40% of the population, we will have seen cumulatively 14% of the income, and 14 is somewhere there. And then 60% of the population accounting for 28% of the income. 28 is right about there. And then 80% of the population accounting for 52% of the income. 52, 80 is here, 52 is right about there. And then of course 100% of the population accounting for 100% of the income, and that's already there. So these are the in-between points, and then what remains is connecting these points. Now, it's worth noting that we are working with an example with information on 5 groups, the 5 quintiles, and we are not working with any further detailed information. In other words, we don't know in this example how the incomes, this 4% of national income that's shared by the 20% of the people at the bottom, we don't know how that 4% is distributed among the 20% of the people. Similarly, we don't have any further details about how income is distributed within any of these individual groups. In the absence of that kind of detailed data, we will simply assume, for simplicity, that the income, the 4% income shared by this poorest group is shared equally. And this 10% income that's shared by the second 20% is shared equally among the people in the second group. Similarly, the 14% shared equally, the 24% shared equally, and the 48% shared equally. What that translates into in terms of the drawing is that when we look at the poorest group and we say the income is shared equally, then no one has any more income than another within this group. And so as we keep adding them up in terms of number of people and add up their income, they would be added up proportionally. They would keep rising at the same rate. In terms of the drawing, it boils down to a straight line. So by making the simplifying assumption of equal income among everyone within this group, the diagram becomes a straight line connecting these 2 points. Similarly, the assumption of equal income within the second group, and then same for the third group and fourth group, would mean that we simply draw a straight line connecting these points. If we had more detailed information for even smaller groups, so let's say deciles, groups, 10 groups of 10% of the population, then we would have had more points to plot, and so the curve would have looked more complete, or a little bit more like a smooth curve. And so if you had detailed information even beyond deciles, then you could really get the smooth curve that would capture all of the population. In the absence of that kind of detail, we have 5 segments here based on the example we created, and we get 5 line segments as a result, straight lines. So straight line, straight line, straight line, straight line, straight line. Each one is getting a little bit steeper, and the increasing slope or the increasing steepness is capturing the fact that each successive group has a little bit more income than the previous group did. So as we start adding up their incomes, it begins to rise a little bit faster, and that's what we see in the slopes. And this curve for this example is the Lorenz curve, which is what we were looking to construct. And it's falling between the Lorenz curve that would have captured perfect equality and the Lorenz curve that would have captured perfect inequality. And so the purpose of Lorenz curve is exactly that, to give us a visual sense of income distribution, to give us a visual sense of the income inequality. And the question of, well, where is the income inequality here? Look at the gap between this Lorenz curve for our given example and the benchmark case of perfect equality. The deviation of the given Lorenz curve from this diagonal is giving us the degree of inequality. The farther it is from this diagonal, the more unequal the distribution is. The closer the Lorenz curve is to the diagonal, the more equal the distribution is. So if you had a situation where a country had this Lorenz curve, and either a different country or the same country at a different point in time had a Lorenz curve that was farther out, more convex, strictly outside of this Lorenz curve, beyond the 0 and the 100 points. And if that were the case, then we would say the one that's farther out, that's more deviated from the diagonal line, the one that's more convex, more curved, is showing greater degree of inequality. The one that's less convex, the one that's closer to the diagonal line, is capturing greater degree of equality, or you can just say less inequality. One other thing to note is that if you had 2 situations where the Lorenz curves are crossing, then visually it may not be easy to tell which one is capturing greater inequality versus smaller inequality. And so that's the type of situation where being able to measure the overall deviation, being able to measure this gap, the gap that is between the perfect equality case and the actual Lorenz curve case, being able to calculate or quantify that gap becomes very, very useful for comparing 2 or more situations. And in fact, that's where we get to the concept of Gini index. Gini index quantifies this gap that's there visually in the Lorenz curve drawing and provides a number for the degree of inequality, and that's something that we will look at later.